Hello, today I'll be talking about my work on the topic validating physiological stress detection model using cortisol as stress biomarker. Stress can be defined as the physiological and psychological reaction of the body to stressors. Repeated exposure to stressors, both positive and negative, results in repeated activation of HPA axis and subsequently leads to increased cortisol levels, which finally leads to chronic stress situations. Chronic stress has several physiological and psychological effects as shown in figure 1. The traditional approach for stress detection is by employing self-reported questionnaire. The limitation is that the interpretation of score is required from experts and also unobtrusive real-time feedback is not possible. The more modern approach is to use the self-feedback report from users to train features of physiological signals. The limitation is that the ground truth estimator from self-reported questionnaires might not be reliable. In this work, we have used cortisol, which is regarded as the gold standard for stress detection in clinical trials. Our proposed work is capable of generalizing stress prediction for a population sample that is not in the training class. We propose the following hypothesis. Given two sets of subjects A and B such that B not belongs to A, it is possible to develop a stress model M trained on A with its physiological response that can generalize to the stress response of B with significantly good accuracy. This work is published in the IEEE International Conference on Consumer Electronics held in Las Vegas this year. The experimental protocol adopted for this study consists of 4 broad phases. Waiting period and pre-stress is for 20 minutes, followed by anticipatory stress for 10 minutes, subsequently a stress period for 10 minutes, which is followed by a recovery period of 40 minutes. The two types of data collected are the physiological signals and the cortisol sample. Physiological signals collected are GSR and PPG through fingertip sensors as shown in figure 4. Cortisol is collected by placing a swab under the tongue for about 2 minutes. 5 cortisol measurements were taken throughout the study. The overview of the model is shown in this figure. It consists of 3 main phases: data preprocessing, which does the normalization, filtering and integration of the physiological signals; feature extraction, extracts the features from GSR and PPG signals and selects the most important features. Finally, the model is trained and tested. The 8 features extracted from GSR are the peak frequency, mean, RMS, and range of peak time interval, and mean, standard deviation, RMS of range of peak values. These features are calculated on the first derivative of GSR signal using a running window of 30 seconds and overlap of 15 seconds. Using the same window length and overlap, 9 features are extracted from PPG signal, which includes mean heart rate, range of heart rate, range, standard deviation, and RMS of HRV, and mean, standard deviation, RMS of systolic peaks. Algorithm 1 shown here is used for selecting important features. It ranks features based on the ANOVA F value of the predictor and the target class. Duplicate scores are removed and top K features are selected. For ground truth estimation, out of the 5 samples, the first 2 are averaged and subtracted from the remaining 3 samples. The 3 samples from all participants were integrated and the mean of the population is used to separate the stressed class from the not stressed class. Data from 10 participants was used for training a random forest classifier with 100 estimators and a maximum depth of 30. The trained model is tested with the remaining 3 participants. Top 5 features were selected as an input to the machine learning model. The overall accuracy achieved is 92% with precision of 93% in distinguishing stress states. Table 1 shows the performance metrics. Our proposed work improved the work presented in the existing literature by reducing the number of input signals to 2 instead of 3, number of features from 15 to 5, the acquisition window length was decreased from 300 seconds to 30 seconds, and the accuracy was increased from 86 to 90%. In conclusion, this work validates the potential of a generalized physiological stress detection model achieving an accuracy of 92%. This model won't be required to be trained separately for each and every individual. Thank you.